and so it seems that you are the only one attending today, but we will see. Maybe that somebody joins later. Anyway, we start, and what is most important is that everything is recorded here. Okay, now let me share the screen, and I want to start with, 1 second, okay, here we are. Perfect. I want to start by going back to what we did yesterday at the end of the lecture, because it was basically an introduction to probability. And we basically, okay, Rada, welcome. I just started. So it was an introduction to probability. Let me just go back to the Excel file that I used yesterday, and it's a new one actually. Let's check. Here we are. So yesterday we introduced probability by introducing Kolmogorov actions, and what we said is that probability is defined as in reference to an event. So we consider a given event, and it's a natural event. So it can be an extreme precipitation, an extreme wind, whatever, extreme wave, whatever. And then the first thing that we do is to associate to this event a number. And the reason why we associate a number is that in this way we can deal with it analytically, because of course, if we consider like an hurricane or a wave storm, and we just look at the event, we observe it, we can perceive the event, we can perceive that it's extreme, but we cannot handle it mathematically. What we need is to measure it in a way, and in order to make this measurement, we need to associate the outcome from the event to a real number, a number. It can be an integer, okay? And therefore, this association allows us to analyze, to treat mathematically the event, the natural event that we want to describe. Remember that our purpose is to make a design project of a structure or an infrastructure that has to be resilient against that event. So we need to manage the event mathematically, determine the frequency, determine the magnitude. So we need to associate it to a number. So this association gives rise to what we call a random variable. Why a random variable? Because we consider this event as a random event, something that we want to analyze by considering that it's random. Look, this is something that it's not, I mean, the unique approach that we can take to analyze the event. There might be another approach to consider the event like a deterministic one, right? A model that allows us to treat the event with a mathematical relationship with no uncertainty. I mean, with precise description. So, I mean, there is the probabilistic approach on the one end and the deterministic approach on the other end. Okay? So there is, on the one hand, the decision to treat the event through a random variable. And on the other hand, there is the alternative of still associating a number to the event, but treating the number as something that is deterministic. So it can be precisely determined. And this is what we do with climate, actually. With climate, we can generate scenario future climate by using a given global model. It's deterministic, and then we get a precise number. But given that we are aware there are several models available, we can take the decision of comparing the output of different models. And therefore, we obtain not a precise number, but a set of numbers. And then we have to choose among them. And how to choose? A possibility is to treat these outcomes as random events. And I try to estimate the most likely through probability, okay? But still there is this association between an event and a number. And this number is a random variable if we decide to treat the event probabilistically, or it's a deterministic variable if we decide to consider the event as something certain with a precise relationship. I anticipate, as you already know, that in engineering, very often, we cannot determine precisely the loads over buildings, over structure, infrastructures. So think of an earthquake. Unfortunately, we cannot determine with precision what we can expect as intensity of an earthquake. And therefore, what we do is to treat it as a random number, a random variable. Okay, so with this introduction, I introduced the concept of random variable. So we consider the event as something random and associate the event to a number. And the number is a random variable because we consider the event as a random one. Example of random variables, wind speed. It's a random variable, and it's something that allows us to treat mathematically the outcome from a windstorm. Rainfall is a random variable. We measure the depth of water that accumulates over the ground during a rainfall event. Okay, now, yesterday, what I did is to introduce probability of these random variables, okay? Because even when I made the example of tossing a dice, basically the event is tossing the dice, and the possible outcomes are the 6 spaces. But in order to deal with it mathematically, I associate to each space a number from 1 to 6, okay? And I defined the probability of these random variables, random outcomes that can be integer or can be real by using Kolmogorov axiom. And I said probability is a number greater than 1. And the probability associated to something certain is 1. Actually, the axiom, the second axiom is formulated in a different way. I said the probability of occurring at least one of all the possible outcomes is 1. It is another way of saying the probability of a certain event is 1. And then I introduced the additive properties. If two events, two results, two random variables are mutually exclusive, it is the case of the dice, because if I get a 1, I don't get a 6. If they are mutually exclusive, the probability of having either, for instance, 1 or 2 is equal to the probability of getting 1 plus the probability of getting 2. And I said, as a consequence, that this probability gives us an idea of the likelihood of each outcome, okay? And basically, I also said, how can we estimate this probability? One possibility is to estimate the frequency, okay? And another possibility is to come out with a perception, a perceptive estimation, like outcome from an election. But I have to make sure that this probability that I estimated based on my perception are complying with the Kolmogorov actions, which is fine. And this is what I introduced as probability. Today, I want to make some more examples. I want to start this lecture with some more examples on Excel. And let me simulate in Excel the outcome from tossing a dice, okay? And this example that I am making is useful for two things. First, we start working on the PC because the purpose of this lab is to get very skilled in working with the PC. It is a challenge because it's only 24 hours, but we have to fix the target of getting very skilled working with the personal computer, okay? And don't be concerned by the exam. The exam will be something that will reflect the mark, your dedication to it, but don't be afraid. And I don't want you for the lab to be afraid by the mark. I just want to try to stimulate in you the interest in getting skilled with the PC, okay? You may decide that it's not relevant, and I would say, look, if you really want to get, first of all, a very skilled engineer today, you have to be very good with the PC. And with very good, I mean that you have also be able to code with different programming languages. This is a very powerful added value to your CV. And, you know, one thing is if you write on your CV capability to use Windows and Word and Excel. And another thing, if you can write, I am an expert of using Windows, Linux-based operating systems, and Mac. And I am very skilled in using Word, Excel, programming in Python, programming in Matrix, programming in R. This is really a different story. And of course, you cannot, if you write that you can code in Python, you have to be able to do it, because otherwise, during an interview, they may check, or they may ask you very simple questions about coding, and if you cannot reply, of course, it's not a good thing. But if you are really prepared and you write it in the CV, it's very good. And, you know, it is important today for finding a job, even for finding an internship. If I can say to an industry or company, look, this student is really very good in coding. So if you have any need for coding, this student is completely independent, can develop a code for you. They are more willing to take you for an internship. Otherwise, everything becomes more complicated. And in particular, when dealing with climate variables, I mean, there are some commercial softwares that allow you to estimate these project variables in a manner that doesn't require that you are able to code. But indeed, if you want to refer to future climate, these softwares are not available. So you have to be independent and autonomous. And also keep in mind that sometimes writing your own code for getting to your own purpose is much easier and much faster than using a commercial software. So this is the purpose of this lab, okay? So with this exercise in Excel, I go back to my previous reasoning. I want to start to work with you with the PC in a smart way, okay? This is the first purpose of this exercise. Second purpose is to learn some more about probability in a very applied manner, okay? Which is, it's maybe more stimulating. Of course, it is not easy to get you skilled to work on the PC in 24 hours. And it is particularly not easy if you attend remotely, because this is what the previous students reported to me. They said, look, by working remotely, it's not really easy to follow you because you will see, one thing is if you see my hands, and another thing if you don't see them and you only see the results on the PC. And one thing is to listen directly from my voice, and you may ask questions more easily. But let's try, okay? Let's try, and let's hope that we can make some of these lectures in Bologna. Of course, to follow me, you need to have the capability of working on the PC. So you should not only look at the screen, what I'm doing, but you should repeat what I'm doing. Okay. Otherwise, if you don't repeat it, it's much more difficult. Okay. And you have the videos. So if for some reason you miss some steps, try to look back at the video, because remember, our target, don't be concerned by the mark. Our target is really to learn. Okay. Now let's start with this simple exercise in Excel. I want to simulate in Excel the outcome from tossing a dice. And why I'm doing that? Because, of course, if I want to toss the dice 1,000 times, it takes time. Okay, I could take a dice and write down on a paper, and I could make this experiment really without the PC. But with the PC, it's much faster. Okay, so let me try to write here, rolling a dice. You can put whatever title you want, okay? Rolling a dice 1,000 times. Why I describe here what I'm doing? Because remember one thing, when you write a code on the PC, it may be in Excel. What I'm doing now in Excel, it's already coding, okay? Coding on a platform that is Excel, fine. When you code something, if you don't write what you're doing, if you don't write down what you're doing, after 1 week, you go back to the Excel file, and you find a series of numbers, and you don't have any clue of the meaning. You don't remember, because everyone has many things to do. So when you code, it is essential that you write down what you're doing. And especially if you need to share the code, okay? If you need to give the code to another student. So write comments, what you are doing, okay? And if you write a table, write a caption, write the headings. So I write here the title of this column, number, attempt number. Okay, let me enlarge the column. Oops, sorry. Here, okay. And here, let's write outcome. Okay, so this is a random number. Yesterday, we learned how to generate a random number. So first of all, attempt 1, outcome. How to generate a random number between, yesterday, what we learned is how to generate a random number between 0 and 1. It is equal to casuale, open and closed parentheses. Let me increase the size of what I'm doing here. Okay, I have to write return, and then I can increase the size, okay? Again, Rada and Kewani, if you have Excel at hand, try to repeat what I'm doing. Okay, this is casuale. This is a random number between 0 and 1, and it's a real number. It has nothing to do with tossing a dice, okay? So, if I want to generate the outcome from tossing a dice, the first thing that I have to do is adjust the range. The range, yeah, please, you have a question. Casuale is in English. Yeah, in English, it could be random. Let me just check. So the question in the room was, casuale is for Excel in Italian. What about Excel in English? So this gives to me an opportunity to tell you how to find help for coding, okay? So let's write on Google. So first of all, google.com. Let me keep it set. Okay, Google. So, and generation random number Excel. Okay, and then you should find here rand. Okay, this is Gemini. Okay, rand. And you see a relevant thing, rand between bottom top for a whole number within a specified range. So let's write the range, let's adjust the range between 1 and 6, okay? It is generating a real number. So the next step, we will need to round the generated number at the bottom, okay? Because if it generates like a random real number between 1 and 6, it may happen that the first generation is 1.1. I want the integer, so I have to round at the bottom. So 1.1 becomes 1. But then the range is not between 1 and 6, must be between 1 and 7. Do you understand why? Because in order to generate 7, if I round at the bottom, I need to get a higher number than 6. Okay, so let's go to Excel and write here. In Italian is casuale tra, I think, yes, casuale tra. And then I put 1, 7. Insufficient, yeah, sorry, it's 1 semicolon. You see the outcome is 5. Look, in Excel, you can recalculate the outcomes by using F9. So now I am typing F9. Look at what happens. The outcome is changed, you see? 5, 6, 5, 4. I'm typing F9. You see, this is the outcome from tossing my dice. I don't understand why it is already giving the integer. So maybe try to check if it gives to you the same result. It is already giving the integer. So what I would like to do at this, because I was expecting the generation of a real number, maybe that the reason why it's giving the integer is that I didn't give any digit. Let's try to put 1,0, 7,0. No, it's still the integer. Okay, so let's try if rand between gives the integer to you. Is giving the integer?
No.
It's a real number. Okay, so first of all, let's try to understand why. And I go back to Google. And let's see, generate random integer number, Excel. Okay, let's see. Click on the rand between should be, click on the cell where you generate your random number, enter the formula. I think rand between should give the integer, but let me check. Rand between, a random integer number between the numbers you specify. So, because for generating a real number, the function is different. But rand between, I can't check, of course. But rand between should give you an integer, like it happened to me. Can I check on your PC why? Yeah. Okay. Yeah. Okay, we got it. It's indeed an integer. Okay. So if it is an integer, we need to adjust. It is between 1 and 6. Okay. And now you see it. Now, what I want to do is to get a column of numbers. I don't want to press F9 1,000 times. So let me just look at the second row, and then with a cut and paste, I can paste everything. So let me, in the number of attempts, I write plus the upper cell plus 1, 2. And then here I can make a copy and paste. Let's see. Okay. And then I can select the two cells. And you see that after the selection, there is a green square here. I can, sorry. I can extend. And I can extend, I want to extend up to 1,000. So let me go down very quickly. If you lower the mouse, it becomes quicker and quicker. Okay. So I'm getting close to 1000. And let's scroll it down. Let's stop. Okay, here we are. Actually, I copied a little bit more than 1000. So let me delete the columns from 1001 and, sorry, and here. Now I have 1000 generations. Look, let's go back to home, to the cell A1. If you press F9, they change every time, okay? So this is a bit not very handy. Let's substitute the formulas with value in the second column. I want to fix them because otherwise, anytime I press F9, everything changes. Given that I have to order them in increasing order, I cannot order them in increasing order if I don't make the change, okay? So let's try to do this. What I need to do is to select this column with the formula. And in order to make a quick selection, I press Shift, arrow down. Shift, Control, arrow down. You see that I selected all the column. I do it again. Shift, Control, at the same time. Shift plus Control plus arrow down. And with the PC, probably arrow down, you have to press an additional key. Shift, Control. Arrow down. Okay. So this is my selection. And now I can, with the mouse, right-click, copy, and then I can paste values. Now it is fixed. You see, if I press F9, it doesn't change anymore. Very good. Now what I have to do, like I did yesterday, I want to count the number of ones, the number of two, the number of three, etc. So let me order this data in ascending order, because otherwise, if I want to count the number of two, it's too demanding. I have to go down and say, okay, one is here, one is here. A quick way of doing that is that I select the column, again, Shift, Control, arrow down, and I click on data, and then I press here, order. Yeah, question. Say again. See, you select all the column.
Select all the column and copy all of them.
Yeah.
And after that, paste where?
Over the same column. So let me just doing it again. Here is before the substitution. I selected all the column. Copy. And then, without changing the selection, I paste over it. I paste over it.
Oh.
Okay, so I am overwriting. Okay, so home, paste, paste values. I am overwriting it. Okay, good. I'm just checking that everybody, and remotely connected. If you have any questions, stop me, okay, with the micro, because I'm not reading the chat. Okay, now I can order the data. Okay, so data, order, and let's continue with the current selection. Order. Okay, and now it's order in ascending order. You see, I have all the ones, all the two, etc. Okay, so if I want to compute the frequency of one, which is an estimate of the probability, are you following me? Are you? Yeah. Okay.
After computation, we should order it.
Yes. Yes, no problem. Okay. So if I want to estimate the frequency of the outcome one, it is very simple because I have in the left column, I have the count. Okay. So let me go back to the last one to go down to the last one. Okay. By the way, what we did yesterday, what we concluded yesterday is that the outcome of each number from the dice is 1/6. Okay. I generated 1,000 numbers. In your opinion, what is an approximate guess for the number of ones? What is? If the probability is 1/6, what is a guess? I guess my guess is about 160. Okay, let's see.
Yeah.
I am moving down. Okay.
1,000 divided by 6.
Sorry, because I heard that you are talking, but
Yeah, but I think the value
it is very low, the volume. Just 1 second. I need to check why. So microphone. Yeah. 1 second. Give me 1 second because I need to check to change the speaker. Yeah, it is disconnected. 1 second. Can you please try to speak again?
is it like if it is one, the chance of getting one is 1/6 out of if it's like rolling 1 time.
Yes, if you roll just 1 time, if you think to a dice has 6 faces.
Yeah,
So
see.
if you roll 1 time, what is the probability of getting 1? It is the
One.
number, it is 1/6.
See, from 1,000 it's like 1,000/6.
Yes, it is plus 1,000/6. And it is
Yeah.
about 160. Actually, here you see we get 139, which is a good approximation. Okay.
Okay.
Now, the probability of getting 1, I can compute it here. It's equal to the 139 divided by 1,000. Okay, this is my estimate, frequentist estimate of the probability of 1. Now, what is the probability of 2? Computing the probability of 2 would require here to start a new counter from the first 2 to the last 2. So let's do it in a smarter way. Let's compute the probability of not exceedance of 2, which is the probability of 1 plus the probability of 2. Okay. So, and this would be, my estimate is 1/6 plus 1/6. And times 1,000. So my estimate would be some 330, okay? Let's go down. Here we are, 2. It's equal to this one divided by 1,000. And we are very close to 330. Very close, okay? So good estimate. Now let's go with 3. And 3, I would expect something like 0.5, 500. Correct? Because 3 is 1/6 plus 1/6 plus 1/6 is 3/6, 0.5. 0.5 plus times 1,000 is 500. Okay, so let's go down. Here we are, very close to 500 plus divided by 1,000. 0.51, very close. Let's go with 4. Here we are, okay, equal to divided by 1,000. And this is very close to what we would expect, because what we would expect is plus 2 divided by 3 times 1,000. Sorry, there is something that, sorry, without times 1,000. You see, very close. And this is 2/3. 4/6 is 2/3. Okay, let's go with 5. Good. Let's go with 5. It's equal to divided by 1,000. 0.2, very good. And now let's go with 6. It will be 1, correct? 1,000 divided 1,000. It's 1. Good. So I estimated my probabilities. Let me go back to home of the Excel file. Let's look at these probabilities. Okay, they are placed in very distant cells, but in between the probabilities that I computed, there are empty cells. So it is very easy to go to the first cell with the first number. It's just control, arrow down at the same time. This is the first probability. Okay, again, you are in an empty column. You want to go to the first number. Control, arrow down. Let me say one thing here. It's a general consideration on coding. If you want to become efficient and skilled with the PC, you have to learn to do the things very quickly. So this is why I am trying to teach you some shortcuts. Of course, I could have moved to the first cell by just clicking the mouse and scrolling, you know? But it takes much more time. If I do this, I go in the column, control arrow down. And this is the first probability, which corresponds to 1. Second probability, probability of not exceedance of 2, probability of not exceedance of 3, probability of not exceedance of 4, probability of not exceedance of 5, probability of not exceedance of 6. Now, let's, when you have, especially when you have to communicate with people, it's better to show a graph. So let's make a graph of this probability of not exceedance, okay? Let me just make the graph manually for this time, okay? So what are the possible outcomes? Are 1, 2, 3, 4, 5, 6, okay? So these are the outcomes. And let's put here the probability. Probability, okay? And then let's copy them, just copy. So I go to the first probability, I want to get it, okay? So control arrow down, and then I can copy. And then I need to paste it here. And I need to paste the value. So incolla valori, paste value, okay? Now, let's go to the second. The second. Copy. And then I go here, paste value. Let's go to the third. Control arrow down, sorry. Control arrow down, control arrow down, control arrow down again. Copy. And then let's paste it here. Sorry, here we are. Now, let's go to the 4. Control, arrow down, arrow down, arrow down, arrow down. Here we are. Copy. Good. And let's paste it here. Let's go to the 5th. Arrow down, arrow down, arrow down, arrow down, arrow down. Copy. Let's put it here. And then the last one is 1. I remember it. So, and now I would say instead of outcomes here, let's write a random variable. Random variable. Okay, let me expand it. And here I have the probability. Probability of not exceedance. Let's write it. Probability not exceedance. Good. Now let's make a graph. In order to make a graph, we have to select the 2 columns in Excel. Okay, make a selection. And then insert graph. And what you need is a dispersion graph. And let's make it a line. Okay. Here is my graph. The probability of not exceedance, let me just see this graph. And let's put it in another. I don't like handling a graph in Excel over a sheet. I prefer to put them in a separate sheet. So move graph, what I did is click over the graph, right click, move graph in another sheet. Why? Didn't move 1 second. Move graph, nuovo foglio, another sheet. Okay, here it is. It is in another sheet. Now, the probability should never be larger than 1. So we need to modify the vertical axis scale. Okay, so let me click over it. And then with double click, probably. No, sorry. Let me click over it and no. Okay, let me just click over the graph, and sorry. I don't remember how to change the scale. Let me see. And layout. No.
I think make it right click, there is something.
Okay, let's see. But with the right click, no. Let me check. Okay, good. Axis.
Yeah, here.
Max 1. Good. Okay. And also for the dice, we need to limit at 6. Otherwise, it is misleading. Okay. And max 6. Okay, perfect. And
And
sorry, also the minimum.
start one, yeah.
Yeah, 1. Very good. Thank you very much. This is a good way of attending because I can realize that you are really following. And another thing here, we need to modify because the outcome cannot can only be an integer. So we need to, just 1 second. Okay, we need to, okay, 1 unit, first unit is 1. Let's see. Okay, now I am happy. Okay. And so what did we obtain? A graph of the probability of not exceedance for the experiment of rolling a dice. And this is probability of not exceedance, also called cumulative probability, or simply, in some cases, probability. Okay? And the probability of not exceedance, this graph that I created, is the graph of a probability distribution. And it is precisely what we need to estimate. And I said yesterday, it would be nice to get a analytical function interpreting it. In this case, it's very simple. It's very simple because it's a straight line. And I can very easily estimate the analytical relationship that produces this straight line. I know the intercept at 1. I know the intercept at 0 is 0. And the slope can be easily computed because the slope is precisely 1 divided by 6. So if I want to write it, let me see if I have a, yeah. Let me put the camera over the blackboard. Let me check if it's, yeah, the blackboard is there. The analytical relationship in this case is very simple. It is probability of x, where x
Is less than.
Sorry?
Is like x is less than the possible value, yeah? It has to be like for probability of not exceedance.
Yes, and let me see. Yeah, you're right. I need to, let me just check if the camera is, yeah, you're right. This is probability of x. In a formally correct way, I should say probability of lowercase x minor or equal to probability of uppercase x minor or equal of lowercase x. This is generic random variable. This is the generic random variable. So it is the generic outcome. And this is an assigned random variable, assigned value. Assigned value. So basically, for instance, for 1, this would be probability of uppercase x minor or equal to 1. Okay? And this is simply, we can write the probability is equal to 1, 6 times x. And for 1, it is 1, 6 times 1, equal 1, 6. For 6 is probability of capital X minor or equal of 6, it is equal to 1, 6 times 6, equal 1. So this is the analytical relationship that I derived.
But this is the cumulative one, yeah?
Say again, it is the
Cumulative,
cumulative, yes.
because they have the same probability, so that one, that's why it's cumulative. Probability of the non-exceedance less than 6.
Yes, they have, this is cumulative probability. By the way, the probability density would be 1/6.
Yeah.
Because what I want to anticipate, but then we close the discussion here, because for now, I only introduced the cumulative probability. You know that there is another way of expressing the probability distribution is through the probability density. And basically, the probability density, if we indicate it with the symbol lowercase p, is equal to the derivative of p over x. Okay, so probability density of a generic variable of a generic variable x is the derivative of the cumulative probability over x. And you see that in this case, it's equal to 1/6. So the probability density is the same for all the possible outcomes, and is 1/6. But this is something that I want to discuss more. Okay, I just wanted to anticipate it. Now, what I really would like to make sure is that you got the development for defining the probability density. And of course, tossing a dice is a simple experiment. And the next step, which I would like to invite you to think about it, is to make the same construction, same graph, for a generic real number between a range, within a range, which can be, a range can be from 1 to 6. But the challenge is not to limit to the integers, but make it for any real number. Okay?
Okay.
So if you want to make an exercise, try it yourself. Okay, let me just conclude this first practical experiment with a final consideration. As you have seen, it took to me some time to copy these probabilities for each outcome from the columns here on the left. It took to me some time. So my question is, if you were forced to complete the same operation in less than half of the time, can you think of something quicker? And I tell you what I would do. Okay, so let's forget about this. Okay, I delete it.
Okay.
So how can I make it very quickly? First of all, I would suggest to save it, because now we are trying to. First thing that I would do is the computed probabilities are formulas. We need to convert them in numbers. And in order to do it very quickly, what I would do is select the first column, shift, control, arrow down, extend to all the columns, and then mouse, copy, and paste values. Okay, perfect. Now I converted everything into numbers. Good. And now what I would do is simply this. I go to the columns of the probabilities, and the control arrow down, I go to the first probability. Perfect. I removed all the rows that are up of it. So all of these rows eliminate entire row
Then you make.
That's it. Second thing that I would do, if you want later on, I can repeat, okay? I go just below the probability, the first probability, and then I select all the next rows that I need to eliminate.
Control the array. Okay.
I would use Control Shift arrow down, and then F4. F4 is a repetition of the last operation. Again, I go here, Control Shift arrow down, F4. I go here, Control Shift arrow down, F4. I go here, Control Shift arrow down, F4. Again here, F4. Look, very quick. Okay, let me repeat it. Okay, so first the conversion of the probabilities, and let me check if they are already converted or not. Yeah, they are already converted. So let me make it again. I need to remove all of these rows. So I go on column E, where I am expecting to find the first probability, Control, Shift, arrow down. I selected all the rows. Be careful, because if you make Control, Shift, arrow down, you go over the number that you want to keep. So you have to keep Shift pressed and go one row above. Okay, and then eliminate it, entire row. Now I go here, Control Shift arrow down, one step above, F4,
Okay.
arrow down, F4.
Okay.
Here we are.
Yeah. F4 is for delete.
Sorry?
F4 is for delete.
F4 is a repetition of the last operation that you made. So, for instance, if you write here, if I want to eliminate this number, I press canch, or I can do with the mouse, eliminate. Okay, and then I would eliminate just, okay, sposta le celle a sinistra. Okay, that's fine. Now, if I want to eliminate again this number, the last operation that I did was a delete. I go over the number I want to eliminate, and then I press F4. And then I get the repetition of the last.
Okay, I understand.
Remember that usually when you deal with software, you have several alternatives for doing the same operation. So here we explored one alternative, and one alternative to the previous one, which is much quicker. Remember that usually you have several quick options. For instance, there are some people that hate to use the keyboard. They want to do everything with the mouse. There are other solutions for rapid selection with the mouse. I am the type of person that doesn't like the mouse, and therefore I try to use the keyboard. So what I suggested to you, Control Shift arrow down, is keyboard, because it's based on my interpretation. And you can, of course, find your own way of doing things. It's not really, it's not really mandatory to. It may be that to follow me, maybe that you can find a quicker way. And what it is very important is the first step that we made together, because we passed from taking like 5 minutes to make an operation, we passed to taking half a minute.
Yeah,
and
1 minute, 2 minutes. Yeah.
Can you imagine when you work at the end of the day, how many hours of work you saved? And this is something that is very important in your skills. If you can say that you are very skilled with the PC, it means that you can quickly, and maybe quicker than others, perform operations. this is really an added value in your background. You have to learn it you have to learn in your profession to be quick and without any negative implication of the quality of your work. There is a proverb in Italian which says "Presto e bene non stanno insieme." It means quick and well done are not compatible. Presto e bene non stanno insieme. It is wrong. I think you can be quick and rigorous. You have just to find the way of making it. And if you succeed, you will become a great engineer and you will never find any problem to get a job. I tell you, for sure. Okay.
Okay.
Instead, if you are very slow, if you forget things, if you miss the deadlines, this is really a bad implication in terms of a job and moreover your personal life, because one thing is work all the day for doing nothing, and another thing is work just half a day for doing a lot of things. Of course, the second is preferable, and it is possible. You just need to exercise. Okay. Now, I would like now to close this Excel file. It's fine for me, and let's move to another important thing that is
One question over here.
Yeah.
One question over here. I don't know. Their graph is, I think it's not here. It's on another, the graph on the graph.
Sorry, on the graph. I think the graph was disappeared. I'm sorry.
Yeah, no problem. But I need only on the meaning of that, when the graph is like linear, it's like line, which is
it's a straight line. Yes.
Straight line. But I think it has to be, for me, is like it has to be point. I feel like that way because we are only 6 pointers, so why we make it line? It has to be the point.
Yeah, you are right. I fully agree. I would say that my personal preference would be for an histogram. Why is that? Because the points sometimes, in terms of communication, efficiency in communication, are not very good. I think an histogram would be better, but it's just a matter of personal preference. For sure, I agree with you that a line is not appropriate. Yes. Yes.
Okay. Good. Yeah, I feel in that way because we don't know, we don't have any values between 1 and 2. So we don't make, or histograph is okay, because it only refers that point. Yeah, you're right. Thank you.
Yeah, an histogram can be the same thing as points. It's just a matter of personal preference,
Yeah.
Okay. Very good. Very good. I fully agree. Okay, let's close this Excel file then, and then let me introduce a second thing which I want to I give you a lot of value. Okay, so a lot of value for this course and in general. So what is the second thing that I want to introduce? It is related to operating systems. Okay, and operating system. What is an operating system? First of all, I will make available a lecture which is already there, but it's not yet accessible in my website. It will become accessible maybe later today, okay? So what I'm saying now is already documented in the lecture notes. So what is an operating system? So and this is a completely different topic, okay? So I'm switching, because I think in order also to keep the things interesting, we need a variety of topic, okay? So operating system. Operating system, let's go to Wikipedia, okay? And operating system. Good. Read here. An operating system is a system software that manages computer hardware and software resources and provides common services for computer programs. So in our PC, there is an operating system, because otherwise if there was not an operating system, we wouldn't be able to manage the PC. The operating system is what, for instance, when I press a key on the keyboard, gives an order to the machine. So the operating system is like an interpreter. Okay, so you see here this graph, hardware. There is the operating system that talks with the hardware. And the hardware, of course, provides the tools to the operating system. And the operating system talks with the application. And the application is Excel, for instance. Okay? And the application talks with the user. Actually, there could be a direct connection between the user and the operating system. Because, for instance, in here, when I click on the mouse over the file manager, I am talking with the operating system. I'm telling the operating system, please start a file manager. So this is a direct connection, okay? But this graph is useful. And so you see that here there is a longer description, but let's forget the rest of the description, okay? The important thing is already defined. And look here, this is very interesting. As of September, sorry. As of September 2024, Android is the most popular operating system. Android actually is a mobile phone operating system, okay? But it doesn't matter. Mobile phone is like a computer. Followed by Microsoft Windows at 26%. Windows is what I'm using now here. I'm not sure about you. Are you using Windows here? Yeah, Windows. I'm not sure about you at home. Anyway, Windows is what I am using. And then you see, let's forget about this operating system, iOS, which I don't know actually. iPad OS, I don't know. Mac OS is Macintosh, okay? It's Apple operating system, 5%. And Linux has only 1%, okay? Just to know that usually we assume that we use Windows, and we even don't know that Windows is an operating system, okay? But in reality, there are alternatives to Windows. For instance, over the phones, you know that there is Windows, but Android is becoming the most popular. By the way, Android is derived from Linux. I will describe what is Linux, which means that indeed Linux is not only 1%. And also Mac OS is derived from Linux. Let's see what is Linux, what is Windows. Okay, let's move forward. Definition, let me see if there are other statistics here, because it's important. Distributed system, embedded real-time library, history, okay. It's everything is quite nice here, it's interesting. So I leave it to you to read if you are interested. It's not really necessary that you read the history, okay? But what is interesting, let me see if I have, if there are other statistics. What is interesting that I want to say is, what are the features of these operating systems, okay? Security, and let me see security. What are the features? Linux, okay. Popular operating systems, okay. So again, here they put the statistics. Linux. Let's see, because what I said, Linux apparently is not much used, but I said, look, Android is based on Linux and also Mac OS. So it means that Linux has some interest. Let's read here. Linux is a free software. Free means it's open source and you don't have to pay for getting it. Windows, you know that you have to pay, not much, but you have to pay, okay? Is released under a general public license, the GNU General Public License, which means that all of its derivatives are legally required to release their source code. The Mac operating system, we don't have access to the source code, and it's also Windows. We don't have access to the source code. This is not really important for us. I mean, we don't need to access the source code. It is interesting for us that one is free and the other one are not free. Why it is interesting? Because when a software is free, it's easier to communicate with people. It becomes more transparent, and it's accessible, especially when there are reduced resources. This is interesting. Okay, perfect. Let me see if there are. You see here, Android is a partially. Sorry, Android is a partially. It was saying that. Let me see, Android. It was saying that is based on Linux. Okay, here we are. Let me avoid to make selection. What you see here, Android is a partially open source operating system closely based on Linux. Okay, and Microsoft Windows. Okay, let's forget about it. But what is important to know is that Linux has an interesting feature. What is the interesting feature? Keep in mind that almost 70% of the web servers, so the servers, the supercomputers, Leonardo, etc., use Linux. Why? Because it's more computationally efficient. And why it is more computationally efficient? Because it doesn't dedicate much resources to user interaction. Is basically less user-friendly. Linux assumes that the user is a skilled user and therefore dedicates less resources to user interaction. Let me give you an example. Linux doesn't have the undelete option, which is a very useful feature in Windows, but it is particularly useful if you're not skilled, because if you are skilled, you know other ways for undeleting. And I will explain to you. I am a Linux user, and I'm not concerned by the lack of undelete. I will explain to you. But basically, it is based on automatically saving. You save frequently, and then you can recover. You can in a way, undelete. But anyway, Linux is a lot more computationally efficient, a lot. And there is another reason. It is more computationally efficient because it doesn't need antivirus. Why it doesn't need antivirus? First, because it is less diffused. Second, because it is much safer. So it is also more efficient in getting self-protected. Doesn't need an antivirus software. And therefore, you start saving resources, computational resources for antivirus, computational resources for user friendliness. I tell you, I have a PC that is quite old and has a dual boot. And I can boot the PC in Windows, or I can start it in Linux. It is amazing the difference in terms of time that it requires to make computations, like opening programs. I open Excel, in Linux is much faster. And another amazing thing is the speed of the fan and the noise of the fan. When I start in Windows, because it gets cooler and cooler, because it takes more energy and whatever. So what is the moral of the story? For big data analysis, all the researchers use Linux. And given that climate change is a big data problem, because global modeling and now we can resort to satellite remote sensing to get a lot of information. And you know the popularity of big data and artificial intelligence today. So it means that all of these things, all the artificial intelligence softwares, they run over Linux. So you understand that as an engineer in the third millennium, you need to get to be able to use Linux. You don't have to forget Windows, because another important thing to remember, each operating system has its pros and its cons. So Linux has these important pros, like, these important advantages, so we can understand better each other. So advantages like computational resources, it's more safe. And I tell you, now also Windows is safe, but it is reassuring the fact that you don't have to be concerned by viruses. But what is the disadvantage? The disadvantage is that it's less diffused. So sometimes for compatibility, we are forced to use Windows. And I tell you another reason why I have the dual boot very often. Because after the pandemics, Microsoft released some Teams, which is quite good, but under Linux it runs, but it is not so good. It's much better to run it under Windows because it was conceived by Microsoft. So this is why when I really need high performances in Teams, I boot my computer in Windows. And therefore you don't have to forget Windows. But once again, if you can write in your PC, knowledge of the Windows, Linux, Mac operating system is much better than routing only Windows operating system, because the companies know the difference. I mean, if they are very good, they know the difference, and they have some Linux computers, and therefore it is an added value for you, especially because it is very easy. I mean, now, today, even if it's less user-friendly, it's much easier than in the past. In the past, it was conceived only for very experienced users. Now, I mean, my wife, she is not skilled to use the PC, but she started with Linux, and now she uses only Linux, not Windows, because she feels like, no, another one, no, I got experience in Linux. So we have to try it. How to try it? First of all, if you have an old machine, my suggestion is get back out from your shelf the old machine, which you put in the shelf because with Windows it doesn't work anymore, and get Linux over it. It can still be used, because even with personal computers that are 15 years old, I tried, it goes up and it works. So this is the first option. Second option is that, as I did at home, you make a dual booting in your personal computer. Dual booting means that when you turn the PC on, you can select either Windows or Linux. It is not easy, and the problem is that you have to reinstall Windows. So this is something that is not very quick. So I wouldn't suggest you to go this way. My first suggestion would be the old PC. But there is also another possibility which we start exploring now. And the other possibility is to install a virtual machine on your PC, and with the virtual machine, you put Linux over it. This is what I do with my Linux PC. With this portable PC, I have a virtual machine running Windows. And when I need Windows, I start the virtual machine and I run it. What is a virtual machine? And don't be concerned by the term virtual. I mean, virtual machine is a very simple thing, and I will show you right now. So let's look on Wikipedia. Virtual machine. Virtual machine, Wikipedia. And here you can get some information. You see, in computing, a virtual machine is the virtualization or emulation of a computer system, computer operating system. Virtual machines are based on computer architectures and provide the functionality of a physical computer. You have the same functionality, okay? Their implementation may involve specialized hardware, software, or a combination of the two, but actually it's very easy. Now, let's I will, in the afternoon, what I want to do is on my personal computer. I cannot install a virtual machine in these room computers. We are not allowed to. I asked the university, can you please give me the permission because I want to work with the student? They said, absolutely no, and use your own PC. Okay, fine. And so what we have to do is, very simply, first of all, install a software on the PC that allows us to create a virtual machine. It's a very simple install, like double click and it goes up. It's very simple, okay? And what are the software? There are two options. And personally, let me see if there is already here the software process, virtual history, migration. Okay, no. Okay, so first option, VirtualBox. Oracle VirtualBox is open source, it's free. So you go here, Oracle VirtualBox, and then download. Very simple. And then you have your operating system, okay? And it should be Windows host. Yes, the host is the hosting machine. Okay, so in this case, if I had to install it here, it's Windows. You see, it's downloaded. And then I could click over it. Okay, let's see what happens. 1 second, download here. Okay, you see, administrator rights, I cannot do that. But in your PC, you can do that. Take the default and you can install it. Okay, this is VirtualBox. Second alternative, I mean, I have no preference. Some people say I use VirtualBox, but I mean, some people say that it's the best one. Other people say, no, I prefer the other one here. And I have VirtualBox. So today in the afternoon, I will, 1 second. Today in the afternoon, I will use it. Second option, VMware. Let's see, I think. Okay, allow all. Products, let me see. No, let me search for VMware virtual machine. Okay, let's see. What is a virtual machine? Fusion and workstation. Okay, let's see. I think it is this one. Run Windows, Linux, and other virtual machine with, okay, workstation. Download now. I think it is already downloaded. No, this is, I don't know why. Let me see. As you see, I'm less experienced. Let me see. Products, private and cloud foundation, advanced services, resources. Let me see. Because the VirtualBox is also sold. And what is it? Let me see. Let me just see here that, no. This is not the correct link. We have to find the correct link for, I think it is, no, Workstation Pro. Let me see here. Okay, let's see that we use VirtualBox, okay, today in the afternoon, because I can find the link. In the afternoon, I will find it, but in any case, I prefer, in any case, given that it's better for you to follow me on the VirtualBox, see all products, let's see. Okay, let's forget about it for now. Okay, so if you have some free time, install VirtualBox. So today in the afternoon we are ready to get it. Okay, and I will show you that it's very quick to install a virtual machine over it. Okay, any additional question before the break? And we start again at 2 p.m. sharp. Okay, thank you. See you later.
See you, ciao.